Welcome again to Milford Model Railway. As you can see, I've acquired a diesel locomotive stable now, but that's another story. It occurred to me as I read the specs on the locos, such as the Deltic in the background there, that produce something like 3,000 brake horsepower, that the steam train has to produce a similar amount of horsepower, and all from the cylinders driving the driving wheels there. Everything else on the loco is a support system for those cylinders. So that led me into looking deeper into the power of steam. So I guess I built me a engineering folly of various steam engines and associated equipment. There's a steam boiler designed for a small model boat, 3 steam engines, and a turbine, steam turbine, driving a generator. There's quite a bit of copper piping involved, and it brought back the memories and the pleasures of silver soldering. There's something very pleasing about watching the solder flow smoothly into the joints. The boiler operates at 30 to 50 psi, but it's wet steam rather than the superheated dry steam as is used to drive steam locos with typical operating pressures of 250 psi. This is a small twin-cylinder marine engine. Here, its speed is controlled by a flyball governor. A little large, I would say, for that engine. But the same principle is used on many steam engines. As the flyball slows down, it opens a valve to allow more steam to enter the cylinder, and vice versa. A simple but clever device. Simple is not easy to achieve. This is a miniature model of a horizontal steam engine, typical of engines installed in factories and mills, which powered the Industrial Revolution. Right now, these engines are running on compressed air, just to prove that, in fact, it is a live steam model. I'll fire up the boiler later. This is a single cylinder engine I built some 25 years ago, and added the reversing gear probably 20 years ago, but I never set up the valve timing. Anyway, I dug it out of the cupboard a few weeks ago, cleaned it up, set up the timing, and mounted it on the display. Here it's running clockwise. The lever is in the down position. It's now running counterclockwise, slower and more noisy. Now clockwise again, clearly more efficient. This is due to valve timing adjustment or lack of, and I'm prepared to accept it. Oh dear, this goes against my Rolls-Royce training. It's either right or not right. Make it right. Near enough gets you fired. A steam turbine. This runs up to 20,000 RPM. It drives a generator geared down to around 2,000 RPM with an unregulated output of 15 volts DC. Here it's operating at a significantly lower speed. Output around 5 volts DC. Sounds like a bearing needs replacing to me. All right, let's fire this thing up. Water level fine. Oil level okay. I don't know whether we have enough gas, but we can always refill if we need to. I don't think we can see the burner, but you can hear it. It normally takes 5 minutes to come up to pressure. It's come off the mark, as you might say, about 10 psi. Gas pressure regulator there is monitoring the pressure in the boiler and will shut down the gas supply when it reaches its maximum, or reaches its set point really. Well, we're up and running there. It can be seen clearly that it's designed to run on steam. There's virtually no clattering of the valve, and it runs a lot smoother, and that's what it was designed to do. The horizontal engine also runs so much more quiet. It's just the difference between compressed air and steam. I can't run the steam turbine on steam. There's all the seals are no good in the, there's probably no seals fitted in the bearings, so steam leaks through the bearings. Well, there we are, running on steam. A little bit of condensate laying around there. I guess I've got to tighten some pipe connections up. That is one pathetic whistle. I guess I got to get me a new one. Here's a couple of traction engine models demonstrating the ingenuity of the steam engineer. Now that's a whistle.